Determining the end behaviors of polynomial functions. Polynomial functions have different end behaviors. So let's talk about a few examples of what we mean by end behaviors of a function. So here we have, for example, we have a graph like this. Okay, and then we have something like this. You can pretend this is a upside down parabola here. Okay, so what we have here is a downward, okay, a downward down behavior. So the behavior end of this type of function is a down behavior function. Now, this can be determined by one thing here, and that is determined by the exponent, by its exponents, and also by the leading coefficient. So let's say, for example, this is the graph of y equals negative x squared. So this is a quadratic here, plus 2x. Now, our end behavior here, it's going to be down, a downward and a downward. So it starts downward and it ends downward. And why is that? Because our leading coefficient here in the function here is -1. Okay. Now, why is it both down? Why is it down? Why not one down and one up? Well, we also need to look at its exponent. Okay, so the exponent here is 2, which is an even number. So when you have an even exponent, leading exponent, right, the highest exponent, okay, you're either going to have an up end behavior or down end behavior. So for example, the parent function here, y equals x squared, okay, is again, it's a positive, even exponent. Okay, so now the end behavior is going to be this time up. So both ends are going to be pointing towards the same direction because of that even exponent. Now because of the even exponent, both ends are going to point towards the same direction, just like here, because this is an even exponent, they're pointing toward, both ends are pointing towards the same direction. Now we just need to know when it's pointing up or when it's pointing down. Well, if the leading coefficient, that first term here, the leading coefficient is a negative, any type of negative number, it's going to be down. And if it's a positive number, so like in this case here, it's going to be up. Now, we have another graph, another function, which is y equals 4x to the 4th power plus 6x to the 3rd power, okay, minus x. Okay, so again, this is an even exponent, means that our end behaviors are going to be both ends of the graph is going to end up. It's going to end up the same directions. And now this is a positive, right? So that means the end behaviors of the graph is going to be upwards. Both ends are going to, so it's going to be something like this, and comes like this, and something like that. Okay, so the graph is somewhere like that if I sketched it out. Okay, so as you can see, even leading exponents have either points upwards, both ends points upward, or both ends points downward. What determines if it's down or up is if it's positive or negative. Okay, so now let's say we have a cubic function which is y equals x3. Okay, now this is an odd an odd exponent, okay? An odd exponent, which means one end of the graph is going to be down or up, and the other end of the graph is going to be either down or up. Now, how do we know where from where? Okay, so if we draw our graph, because it's a positive leading coefficient and an odd exponent, the graph is going to start downwards. Okay, so it's going to start downwards like this, and then it goes upwards. Okay, so this is a down up. This is a down up motion. All right. Now, if it was, let's say, for example, y equals, now this time the same graph, but this time it's what? The same graph, but this time it's a negative. So this means going to be the reverse. So instead of starting from down to up, it's going the end behaviors are going to be up to down, okay? Because of that negative is reverses. So if I do this, okay, if I do this, so it's going to look something like this, right? So you see now it's an up to down behavior. So in summary, if I summarize everything here I'm going to have it like this. Okay, I'm going to split it up. Okay, so this is even exponent, right? Even exponents and odd exponents, okay? All right. Okay, so even exponents and odd exponents, and then we're gonna have, okay, positive, right? Positive leading coefficient and negative leading coefficient here. Okay, so if we have even, it's going to be up for the positive, and for the negative, it's going to be down. Okay, for the odd, the positive is going to be down, up, and behaviors, and then for the negative odd exponents, it's going to be an up, down.